Alright, so on the CP Practice Final Exam, question number 73, or prompt number 73, tells you to balance the equation that we were working with in both 71 and 72 above. Now this same question on the CP exam is the same as the honors exam number 71. To balance the equation, we need to have the products predicted, and that's what we did in number 72. So those products are already there. We're going to rewrite it here just for convenience. Alright, now we're going to make an add an inventory. So we're going to write down a list of each of the elements in the equation. So we have hydrogens, we have sulfurs and oxygens and bariums. And we're going to make a kind of grid here. And we're going to use this grid to count up the atoms on both sides of the equation. The left side of the equation is the left of the arrow, the right side of the equation is the right of the arrow. So over here I can see I have 2 hydrogens here, and the 2 outside the parentheses tells me I have 2 hydrogens here for 4. I have 1 sulfur. Looks to me I have 3 oxygens here, plus I've got 2 over here for the same reason I had 2 hydrogens. The 2 outside the parentheses and the 1 oxygen inside means I have 2 here plus this 3. That's 5 oxygens, and I have 1 barium. On the other side of the equation, I have just 2 hydrogens here. I have 1 sulfur, 1 oxygen here, plus 3, that's 4. And I have 1 barium. Now remember, we're going to balance oxygen last and hydrogen next to last. But everything else is already balanced. So since hydrogen is balanced next to last, I'm going to start there next. So I'm going to put a coefficient of 2 in front of the water. That multiplies everything in the formula, meaning I now have 4 hydrogens on this side. But that 2 in front of the water also changes everything in the formula, meaning we're going to change the number of oxygens. I'm going to recount the oxygens. Now, when I have oxygens in more than one place, I like to list them out to be careful. The more careful you are, the more likely you are to get it right. So the number of oxygens I have here is 2. The number of oxygens I have here is 3. And that's a total of 5. So now we have 5 oxygens, and I can see that the number of atoms on both sides of the equation is balanced or even. So that's a balanced equation now with just this coefficient 2 there.